Moving on to our next type of conic section, we're going to talk about this concept of hyperbolas. And highlight, well, first I'm going to turn on my pen. And we're going to talk about hyperbolas. Now, hyperbolas are not like complete circles or complete ellipses. They almost look like parabolas, but let's take a look and I'll do my best to explain just the basics of hyperbolas. So the first thing we're going to notice is that it does need to be equal to 1. That's very important to be equal to 1. If it's not equal to 1, you'll have to like divide everything by whatever it's equal to, so it does equal to 1. And then we are going to address this idea that x squared is the positive term and y squared is the negative term. The reason we do that is because when we graph a hyperbola, and a hyperbola is going to look like this, it's either going to be kind of this little weird shape or this little weird shape. If the x squared term is the positive term, it's going to be this little weird shape. And if the y squared is the positive term, it's going to be that little weird shape. And we're going to get specific about where to graph them. Try my best here for you, okay? Now, you might say, well, how come this isn't an ellipse? It looks super similar to an ellipse. That is because of the minus sign. If it was an ellipse or in a circle, that would be a plus sign. So a minus sign is going to, a minus sign when they're both, a minus sign when they're both squared means you're going to have a hyperbola. Let's talk about this particular hyperbola more specifically now. I'm going to say the center of it. I don't want you to overthink that because a note doesn't even ask for the center. But I want you to just do me a favor, picture the word center. And that means like, where's your hyperbola? Like, where is it going to be all surrounded by? The center is, see how there's nothing being added or subtracted? 0, 0. So it's very similar to ellipses and circles. And I don't even think they use the word center, but for me, it's very important to locate the center of where everything's going to happen. Now, underneath x, we have 9. We know the square root of 9 is 3, and we know the square root of 25 is 5. What that means in context of this particular problem, remember how I showed you those funny shapes? Those funny shapes are funny because they approach what we call asymptotes. So the asymptote is going to be, on this particular case, let's see, we have an x, we know slope, we all know that slope is y over x, right? So in this case, it's going to be the square root of 25, so it's going to be 5 over the square root of 9, which is going to be 3. So I want you to go to your center dot, and you're going to go up 5 over 3. And if we could do it again, we would. But we'll go down 5 over 3. That's your first asymptote. I'm going to do the asymptotes today in red. And then we're going to go the other way as well. Just verifying with the answer key. Okay, so I haven't taught this in a couple of years. So now what we're going to do is going to go down 5 and over 3 the other way. So our asymptotes are going to be a big X, and the slopes are going to be positive and negative of 5/3. So we're going to go down 5 and over 3, up 5 and over 3 the other way. And it's going to go through our center that we located. Okay, so those lines, in fact, what I might do on those lines is make them broken so that you know they're asymptotes. There you go. They're not actually part of my equation. Now to graph this equation, if you really wanted to do it the right way and get really specific points, you would have to plug in values for x and get out values for y. But what I'm going to tell you is because x squared was the positive term, we're going to have a horizontal hyperbola like that. And we need to use this concept of this 3. So I want you to go to your center, and I want you to go on your x-axis of your center and go 3 to the right and 3 to the left. And for what we're learning for context of today, I want to see this point and just give me a shape that approaches your asymptotes but doesn't touch them. Do the same thing on both sides. Is there more maybe in future math class that you'll learn with a hyperbola? Absolutely. I'm teaching you the basics of a hyperbola. So I was able to identify, and those were actually called the vertices, if you want to label those. This is a vertice, this is a vertice. But I wanted to teach you how to find the asymptotes, to understand the shape, and then to understand if it's a vertical or horizontal. That's my goal. Now let's look at number 3. I will try to keep my color coding the same for you. So the first thing we need to do is find the center. The center is going to be at opposite of this, so -4, and whatever's with this, so opposite of that, so 0. So let's go ahead and put a point at -4, 0. All of our asymptotes are going to go from that point. I call that the center of my hyperbola. It's like what everything kind of circles around. Now, it is equal to 1. I want to acknowledge that the x term is technically over 1. So if I take the square root of it, in my x direction, I have a movement of 1. Take the square root of 16. In the y direction, I'll have a movement of 4. So let's talk about the asymptotes. The asymptotes are going to have a slope, and it's going to be plus and minus your y value of 4 over plus or minus your x value of 1. So I'm going to go to the center, and I'm going to go up 4 over 1, up 4 over 1. I think I can actually fit a couple of dots there. Down 4 over 1, down 4 over 1. And I'm going to grab my broken line. That's my first asymptote. I'm going to grab, and now I have to go the other way. So I need to go down 4 to the right 1, down 4 to the right 1, up 4, 1, 2, 3, 4 to the left, 4 to the left. I'm going to connect those ones. Looks kind of silly because I was using broken line, but that's okay. So those are your asymptotes on this particular problem. Remember, asymptotes are lines that the graph approaches but never touches. I'm going to grab my solid blue line now. And we need to talk about if this is a vertical hyperbola, meaning like up and down, or left and right, a horizontal. So can you see how the y squared term was the positive term this time? That means our hyperbola, wow, that was a big struggling point, is going to be like that. So this one's just going to be super skinny because of our asymptotes are so super skinny. So we're going to focus on the y value of 4. We're not going to focus on the x value. We're going to go from our center, and we're going to go 1, 2, 3, 4 up. That's your first vertice. And then we're going to go 4 down. 1, 2, 3, 4. That's your second vertice. Again, if you go to college, you will talk about these a lot more in detail. I'm just giving you an introduction. And your hyperbola is going to approach your asymptotes, but it will never touch them. It kind of looks like a parabola, but it's a hyperbola. There it is. Now, if you're saying, like, how in the world does this come from a cone? If you could picture having 2 cones stacked on each other, like point to point, and let me see if I can draw this for you. And you picture taking like a knife and you cut straight down, like right here. You would see this particular shape when you cut. You would see kind of like this parabolic shape on the top and this parabolic shape on the bottom. So that's why we call it conic sections, because it comes from cutting a cone. All right, let's try number 5. Now, number 5 is just a jerk because it's not in order for you. So what I need to do is write probably pretty small and get this thing so that it looks like number 1 and number 3. And I'm going to do that now. I will notice that the x squared term is the positive term. That means it's going to be a horizontal hyperbola when I'm ready to graph it. And the y squared term is negative. That means it's not an ellipse and it's not a circle. All right, take your time. You did study this with ellipses. So let's get this thing in order. I'm going to put the 9x first. 9x squared minus 18x. 9x squared minus 18x. So I'm putting the x's beside each other. And then I'm going to put the y's next, so minus 4y squared. What was the other y? Plus 16y. And at the same time, I'm going to take this 43 to the other side. Now, for the x's, I'll color code them for you. I'm going to take a 9 out. So I'm with x squared minus 2x. Please leave a space, just like we did when we studied ellipses. For the y term, you're going to take out a negative 4. So you get y squared minus 4y. Okay, now I'm going to switch back to orange. If you remember when we did completing the square with ellipses, I said you had to take half of the middle term and square it. So 1/2 of -2 is -1 squared is +1. Add it here. Do the same for y. Take 1/2 of -4, which is -2, square, and add it to both sides. Notice I haven't added it to both sides yet because I want to make sure I remind you of something. Hopefully some of you are already remembering. Technically on this side, it's -4 times 4, so it's actually a change of -16. So we have to be fair and do -16 on both sides. So our equation balances. This one is technically a +9 because it's 9 times 1. So to balance it, we got to do a +9. So remember what you do to the left, you have to do to the right, just like we did with the ellipses. Now it's time to factor our perfect square. This is 9 times x minus 1 to the quantity squared. You learned that when we completed the square. This is minus 4 times y minus 2, the quantity squared. You learned that before as well. And then 43 minus 16. My calculator's not working. I don't want to chance this, so I'm going to get a calculator. Minus 34. I don't know. One would think that I'd be embarrassed that I can't do the subtraction in my head, but I'm really not. Okay. Equals 43. This is 42. 43 minus 16 plus 9. Okay, so 36. Oh, yeah, we like that as a perfect square. And now what we're going to do is, remember, we have to set this equal to 1, so we're going to divide everything by 36. Each term, and I have 3 terms, the first, the second, and the one after the equals. Okay, 9 over 36 is 1/4. So our x is going to be x minus 1, quantity squared, over 4. 4 over 36 is 1/9, so this is going to be y minus 2 squared over 9 equals 36 over 36 is just 1. I can now go ahead and graph my hyperbola. Take the square root of 4, so our movement in the x direction is 2. Square root of 9, our movement in the y direction is 3. So the x squared term is the positive term. So it is going to be a horizontal hyperbola once we graph it. Our asymptotes are going to be, the slopes of our asymptotes are going to be y over x, in this case 3 over 2. And that all is going to center around +1, +2. So let's plot our center so we have a good thing to look at. So over 1 up 2. That's going to be our center. From our center, we will go ahead and do our asymptotes of up 3, right 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. That's going to be good enough. I'm going to grab my broken line. Remember, the asymptotes are not actually part of your graph. They're simply what your graph approaches but never touches. Do the same thing. Now remember, this, where was our center? Let's see. I'm going to give it a little highlight. This was our center. That way I know where to go with my asymptotes. So I'm going to go down 3. 1, 2, 3, right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, I'm going to connect that. Ah, I did poorly. Okay, that's pretty good. Grab my blue solid line so I can grab it. Remember, this is a horizontal hyperbola because the x squared term was positive. So on the x-axis of your center, remember we're going from your center, we're going to go 2. So I'm going to go 2 to the right. I'm going to go 2 to the left. 1, 2. Those are your vertices. I'm going to make the pen just a little bit bigger so I can graph them. Remember, it's going to approach your asymptotes but never touch them. And it will get infinitely close to them, but it will never touch them. To be honest with you, there is more. I think this video is probably a lot to take in and of itself. So your homework for this week will be doing the exact same things on the right-hand side. I want you to find your centers. I want you to find your slopes of your asymptotes. I want to see the asymptotes and the center graphed. And then I want to see the two vertices plotted. And then I want to see a graph that approaches your asymptotes but does not touch them.